Now members, we are going to see how do we determine the maximum and minimum values of expressions. But before we get into the real examples, I'm going to first take you through the foundation. When you understand this foundation, now the other things are going to be very easy. So let us go through it, and then we shall come to the examples in the next lesson. So here we have, to capture the minimum and maximum values of the expressions, we always first capture the exact value. So we get the exact value of the expression they want us to get. So the following are very important. To maximize a fraction, to maximize fractions, we always maximize the numerator and minimize the denominator, and vice versa. Vice versa means to minimize a fraction, we always minimize the denominator, and maximize the denominator. That's what the vice versa means. Now, this is a very important, it's going to be the basic of all these ones. So, if the exact value, if you have a fraction equal to this and the exact value is positive greater than 0, means it's positive. Now, you see this is a fraction. To maximize t, or to maximize this fraction, what we do, we get the maximum, we maximize the numerator and we minimize the denominator. To minimize it now, why do this? Is that we know when there is something small is divided with something big, the result is going to be big. It's like when you have, say, a 5 divided by 0. Okay, let me give an example here. A good example. When we have 5 divided by 0.2, the answer we get there is what? When you get your calculator and multiply. So the answer we get is 25. Now, it means that this one is big and this one is small. You get something big. Now to minimize, you make something x minimum and maximize this. Look at this. When you have 0.2 straight over 5, the answer you get is going to be 0.04. I think that this one is going to give you minimum. Why the minimum? Because this one is very small, here this one is big. This one is giving you maximum because this is very big, here this is very small. I think you can note those two things. Now, if it's positive, now, if it's positive, and then if it's negative, this works if it's positive. But if something is negative, then the idea changes. Why? Because we know that negative, there's something small is bigger than something big, which is negative. What I mean is, if you have negative 3, this negative 3 is greater than negative 8. That's what it means. In simple terms, we mean to get in negative something which is very small, which has a negative and is smaller. It's bigger than something which is having negative and it's bigger. So this is the idea I want you to apply there. So it means that if t is negative, it means that now we want now something to be small. To get a maximum, that value which is negative should be small. So that's why right now in simple terms here, we minimize this and we maximize this. If we have this, it means that now we are going to be having x max, then we maximize the numerator. This one is min, not max. So this one is min, and then we minimize the numerator as that. And then we minimize the numerator, as simple as that. So that's the case now we have there. So we get this, then we maximize it. This one, if our t is negative, if the value you get for t, the exact value is negative, that's what happens. If t is equaling, if you are adding now, the exact value is positive. If t is positive, you get this maximum, you get this maximum. Minimize, you get this minimum plus this minimum. That is very easy. Now when you come to a difference, always after when you're subtracting and t is positive and the exact value is positive, to get the maximum value of t, you maximize this and subtract of something very small. In that case, when we have, say, 5 minus 0.1. You start to get 4.9. You start to get the value here. When you want to maximize, you get this one max, you subtract something small. When we have this as T minimum, now T minimum means that get something small, and that something small still, you subtract something big. In simple terms, it's like when we have a 5 and we subtract off 8. This is what we are going to get is negative 3. And you say this one is bigger, yet this one is smaller. When we have now a product and this positive, the same idea. If you want maxima, you get the x maxima, then y maxima. X minimum, y minimum, if you want the minimum. Now, I'm bringing in fractions. When we are adding fractions here, be careful. We said if we have t equaling to x over y plus a over b, if we have now, if you want to see that we are adding, sometimes we are adding this to this. What happens if we are adding when we want the maximum? We say maximize the first and maximize the second. Now, if you want to maximize this, what happens if you have a fraction? Now you come back to this, if this is positive. If you want to maximize this, we make the upper thing maximum and we make this one minimum. If you want to maximize this, we make this maximum and this minimum. Hope you copy that. Now, to get this minimum, if we are adding, we said we minimize this and we minimize this, as you see there. Now, what happens if you want this to be minimum? If you want minimum, you minimize this, you maximize this. Minimize this, maximize that. Now, the idea is in the difference there. If it is positive, we are working on this. If it is positive, please don't get lost. If it is positive, we say if you are subtracting, we say if you are subtracting, maximize this and minimize this. Now, if you have maximized this, we make this maximum and we minimize this. Now, if we have to minimize this, we make this minimum and we make this maximum, as you see. We minimize a fraction there. And here, if you want the minimum, now we say minimize this and maximize this if we are subtracting. And the idea is if you have to minimize this, we make the minimum, maximum, minimum, because we want to maximize this. Be careful there. Now, what happens if you have a product and a sum in the denominator? If you have a product, we say, now you start this one, we treat it as a fraction first. Now this is a fraction. It means that we maximize this and we minimize this if you want the maximum. Now, how do we maximize? Now you come to the individuals. How do we maximize this? We get this maximum and this maximum. That happens when we are having a multiplication. Now, how do we minimize this? If we are having a sum, how do we minimize a sum? Get this minimum and minimize that also. If you want this minimum now, we minimize this and we maximize this. If you have to minimize a product, you see the case is there. And if you want to maximize a sum, you say you maximize this and maximize that. Now, let us see what happens if you have this and you're dividing in something which is a difference. So you say maximize this, minimize this. If you have the maximum of a fraction, this is the fraction. Now, we come to the individual terms. We maximize this over, to get the maximum, the minimum of this, what happens? We say you minimize this and subtract off something which is maximum. I think we see here. To minimize this and maximize this. So that when you understand these basics, the rest are going to be very easy. To minimize this, you say minimize this and maximize this. Now, this one minimum. Now, how do we maximize this? You say make this maximum and then make this minimum, as you can see here. If you want to maximize this, if you want to maximize the difference, make this maximum and then subtract off the minimum. What if when we have a difference and in there? So what happens if you want the maximum of this? If you said you want the maximum of this, you said maximize this and minimize this, as in this case here. Then if you want the minimum of this, you say minimize this and maximize this, as is there. And if you want the minimum of this, that is the case. see there. So once we have understood these basics, take time and understand these ones. When you understand these ones, you are going to see the next examples. They are going to be obvious. So we are going to apply these ones. See you there.